In this video, we'll look at some aspects of exponential graphs and log graphs and finding missing variables. And so, for starters, we've got an exponential equation. I noticed that the y asymptote is 2. And so for starters, straight up q would equal 2. I like to just fill that in immediately. So q is the y asymptote. And then any time in graphs, no matter what section, when I'm missing a letter I, sub in a point. And so I'm going to sub in minus 1, 5. 5 is the y value. Minus 1 is the x. I'm going to take the 2 across, so that's 3. And a negative power takes something to the bottom line. And so to get a, I'm just going to do what I call escalators, just swapping places. So a would just equal a third. So there you've got q, that was a quick one, and then a equals a third. We've worked that out, and I've got the equation. Then sketch the inverse. So to sketch the inverse, all you do is graphically, you just swap everything that you've got. So if I wanted the y-intercept here, just to start, which would be really helpful, if this is now my equation, a third x plus 2. If I want the y-intercept, I let x be 0. Anything to the 0 is 1. 1 plus 2 is 3. And so to sketch the inverse, I'm just going to swap everything. If the y-asymptote is 2, now the x-asymptote is 2. If the y-intercept was 3, now the x-intercept is 3. If the point was minus 1, 5, now it will be 5 across and minus 1. And if I play dot to dot, it goes like that, and I'm following the blue graph, the blue asymptote, and so it will look something like that. So here's the equation now of the graph of the inverse. For which values of x will that inverse graph be bigger than 0? And so I can just use my sketch to see where that's happening. And where it will be bigger than 0 is just above the axis. So that's this whole area here. And so the challenge is I'm describing my answer in terms of x. And so I can see that the x value is smaller than 3, even though it looks like it's above 3. The x value that I've highlighted in red would be less than 3. But it doesn't just go on forever. There's this asymptote blocking it. And so it's got to be bigger than 2. To make this question slightly more interesting, if the question said greater than or equal to, then instead of automatically just making these both equal to, you would not make this one equal to a 2 because there's an asymptote, but you would for that one. So that would have been the correct answer if this was greater than or equal to. If they asked us just for practice to work out the equation of the inverse, then taking it from here, what I would have done is I would have said step 1, swap the x and the y. And so actually what I'll do first, because there's this constant term, it's a bit of a headache. I'm going to first take that constant term across so that I end up with that. Let me just keep this in brackets as well. If I do the inverse, I swap x and y, so this will become a third to the y. This is still the original graph at this stage, and this is now the inverse graph at this stage because I swapped x and y. And then if I want y by itself, then I use logs. The base of the exponent is the base of the log, and it never looks the same, so it wouldn't be a y here, so it must be the other side. And again, last thing, just to reiterate, if I needed the asymptote just from here, it's whatever comes out of the bracket. So if this bracket is x minus 2, then the asymptote, if I needed it just without a graph, without visuals, it's just where x is equal to 2, which we can see from what we did when we switched the x and y earlier. I hope that you found this video helpful. If you did, please like it, subscribe to our channel, and share it with your friends.